Today we are going to have a short idea to how to write short notes on Claisen rearrangement. So basically, Claisen rearrangement is a type of pericyclic reactions. It involves 3 sigmotropic shifts. Equally similar. So what we have learned is cope rearrangement. But in Claisen rearrangement, the starting material, that is the reactant used is an aryl allyl ether. When I say aryl allyl ether, that means it must have an aryl part and an allyl part linked with an oxygen atom. Therefore, it is called an aryl allyl ether. Then the product obtained will be an orthoallyl phenol or a para-allyl phenol. The orthoallyl phenol will be the major product and the para-allyl phenol will be the minor product. I will explain this with the mechanism why this is the major product and why this is the minor product. Basically, it involves, as I have told you, it involves 3 sigmotropic shift. 3 sigmotropic shift is well learned in our previous classes. It's a kind of reactions which we have learned in sigmotropic reactions. It's a kind of rather shift which we have learned in sigmotropic reaction. It is thermodynamically involved. One of the most important thing, how to identify that this is going to be a Claisen reaction is this. It is thermodynamically allowed. That is in above the arrow you will find a sign of heat. Then in each, if it involves more than one steps, that is, if the rearrangement takes place only at the ortho position, then we will have one time allyl shift, 3 sigmotropic shift, 3 sigmotropic shift involves only one allylic shift. Whereas if the reaction goes with a para product at the end, if we are having a traces of the para product too, then we will have to have some more 3 sigmotropic shifts with some more allylic shifts. Let's come to the mechanism of this reaction. The mechanism, as I have told you, is a 3 sigmotropic shift. The bond between these oxygen, this arylic carbon, and this is numbered as 1, 2, 3. Then in the allylic part, I have numbered is at as 1, 2, and 3. The reaction takes place as like this. The bond will go this, generating a double bond over here, and this oxygen carbon bond will break to have a double bond over here, and this is going to have a new sigma bond formed between three positions. Therefore, I am saying this is a 3 shift, and this comes under that 3 sigmotropic shifts. With this product, as you can see, is not aromatized. That is, aromaticity of the benzene ring has been disturbed. Therefore, to gain this aromaticity, hydrogen from the ortho position will move towards oxygen, shifting the electron density to over here, and this electron density towards the oxygen, which will finally have this oxygen to have the phenolic group over here, and this is going to be the major product. As I have told you, this is a non-aromatic species, and to have that aromatization, this reaction is very fast. So more than 95% of the reactant will go to have an ortho product. But if by chance or it happens, the probability is before this aromatization takes place, one more sigmotropic 3 shift can occur, that is involving the para position. If the bonds involving the para positions are involved in this 3 sigmotropic shift, then I have written that this species so as to have a better idea of where the shifting is taking place. The this position, the bond will move towards this, breaking this 1 1 bond. Again, I can number is like 1, 2, and 3 to show you the para shift, and 1, 2, 3 to show you the new bond formed is again between 3 3. Therefore, this is again a 3 shift, 3 sigmotropic shift, and you will have this. Similar to that ortho position, this ring is not aromatized. To have the aromatization, hydrogen from this para position will move towards oxygen to give an para allyl phenol. One thing which can be asked in competitions, or rather which can be asked in your question papers is also that is, what happens if this carbon is labeled carbon, and while I am saying this carbon is labeled, that means it is not normal carbon 12, it can be carbon 13. See, the isotopic carbon atom. If this is a level carbon, I am just putting as asterisk marks over here to show that this carbon is different from these carbon. What will happen? You can easily say this carbon which is level is going to be at position number this. Clear? In ortho, during ortho, this is going to be present over here. But while talking about the para position, when the 3,3 sigmotropic allylic shift takes place twice, level carbon is present over here. This I have written this like na? So this level carbon is present over here. This is going to be attached over here. Therefore, the level carbon comes over here, and the level carbon comes over here. So this clearly gives you that in ortho product, the allylic carbon, that is the carbon which is directly attached with the oxygen, will be at the terminal position. But when we are proceeding towards a para product and we are using this, then you can clearly see that this asterisk, that is the level carbon, is now going to attack over this para position, and now the level carbon is going to be directly attached over this para position. Now let's discuss the characteristics of Claisen reaction, which you can use while writing your answer. That is one of the first characteristic, or in general view, we can easily see if one of the ortho position is blocked or preoccupied by some other group, then the reaction will easily occur at the available ortho position, that is the second ortho position. Then if both of the ortho positions are blocked, then the reaction will go toward to have a para product. Easily it will form a para product. And if both ortho as well as para is blocked, then the reaction will never occur. Since there is no chance, seeing the mechanism, we can easily see there is no chance of any kind of 3,3 sigmotropic shift involving the meta position. In this question, we have been provided with a product, and with this reactant, if it is generating this product, then we have to guess what type of reaction is this. It can be, the options are co-rearrangement, Claisen rearrangement, and oxy-co-rearrangement. For answering this, we need to look this problem by two ways. One is to identify by seeing the reactant. The reactant site is, we are having this site. We are having this side, and we are having this side also. So according to the options available, co-rearrangement involves allyl vinyl groups, migration of allyl vinyl groups, and C3C4 carbon breakages takes place, and we can form the product according to this. But if at this position we have oxygen, then this is an Claisen co-rearrangement. Then in simple Claisen rearrangement, we need to have a phenol. The products are, we have this group. We can have a Claisen rearrangement over here. But since in product, phenol is not a product. Therefore, this Claisen rearrangement is of no use. Then oxy-cope is no use. Cope is no use. Claisen cope rearrangement. We have to look this problem as name reaction involving Claisen cope rearrangement, and for this we have to say this in a twisted way, that this pH is written over here, this orthoallylic group is written over here, and this vinylic group is written over here. The migration of this bond like this and this bond like this, formation of a new sigma bond will generate the product. Therefore, according to me, the product must be Claisen cope. समझ में आया कि नहीं बेटा?